Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss few properties on congruence. In our last class, we already discussed some of the properties. This is a continuation class. Please watch that class and come back here. The link for the playlist is provided in the description below. The second property which we are going to discuss, it's very important. We are going to use that property in our next class where we are going to discuss Fermat's little theorem. And the explanation is provided by based on the assumption that you already have some basic knowledge on our previous classes, because the basics to understand this already provided previously. So coming to the first one, this is the property which we already discussed in our last class. We are going to use this property here. If A, B, C, D are integers such that A congruent to B mod M and C congruent to D mod M, if this two happens, then we can say that AC congruent to BD modulus M. The mathematical proof for this is discussed in our previous class. See, understand. A congruent to B mod M, C congruent to D mod M, AC congruent to BD modulus M. Now coming to today's first property, if A congruent to B mod M, if this happens, then we need to show that A power x congruent to B power x modulus M. Here x is a positive integer. You take any positive integer, it is going to be true. A power x congruent to B power x mod M. So why it is true? Let's try to understand. The above property says that if A congruent to B mod M and C congruent to D mod M, if this two happens, then AC congruent to BD modulus M. A, B, C, D are all integer values. You can take any integer values. Don't forget this point. You can take any integer values. So that's why here we are taking it as A congruent to B mod M. In place of C and D, we are taking AB again. Why not? C and D can be any integers which are congruent. A congruent to B mod M. Then this can be written as, from the above first property in the previous class property, AA congruent to BB modulus M. AA means A square congruent to B square modulus M. Similarly, you repeat this. You take this A square congruent to B square modulus M. Then again you take A congruent to B mod M. This can be written as A cube congruent to B cube modulus M. You can extend this formula to anywhere. That's why A power x congruent to B power x modulus M. If A congruent to B mod M, then A power x congruent to B power x modulus M. Now coming to the second property, this is very important to understand and bit confusing also. If AC congruent to BC modulus M, if this happens, then we can say that A congruent to B modulus M. We can say that A congruent to B modulus M only if GCD of C comma M is equal to 1. Then only we can say that. If this happens, then from this we can eliminate C. In easy words to understand, eliminate C. You can directly write it as A congruent to B mod M only if GCD of C comma M is equal to 1. Now we try to understand the mathematical proof. Let's take this AC congruent to BC modulus M. It was given AC congruent to BC modulus M. So from this statement, what is the formula for congruence? A congruent to B modulus M means A minus B is divisible by M. AC congruent to BC modulus M means AC minus BC is divisible by M. Divisible by M means M multiplied by some integer. It is going to get the value of AC minus BC. That is what divisibility means. AC minus BC value is divisible by M means this can be written as AC minus BC equal to M multiplied by some P. P means P is an integer value here. So M multiplied by some P is going to be AC minus BC. Then only we say it as M is going to divide AC minus BC. So this can be written like this. Now take the common, A minus B multiplied by C is equal to PM. P is some integer value, M is our value. So now this can be written as A minus B is equal to P multiplied by M by C. P is just an integer value. Again apply the formula. A minus B is equal to P multiplied by M by C. Means P is just an integer value. A minus B is divisible by M by C. M by C multiplied by some integer. You are going to get A minus B. So from this we can write it as A minus B is divisible by M by C. This can be written as A congruent to B modulus M by C. Just a congruence formula. If this happens, we can write it as A congruent to B mod M by C. So modulus can apply only for integers. We don't know whether M by C is integer or not. So this can be applicable only if M by C is an integer value. That means C divides M. When M by C is going to be integer value, definitely C has to divide M. Then only M by C is going to be integer value. Simple division logic. That means C divides M. Since C divides M, GCD of C comma M is equal to C. If C divides M, then definitely GCD of C comma M is C. That is what GCD means. See here. For example, 8 comma 24. 8 divides 24. What is the greatest common divisor? 8 is the greatest common divisor. GCD of 8 comma 24 is 8 because 8 divides 24. If C divides M, then GCD of C comma M is equal to C. Now we are going to write it as A congruent to B modulus M by C. This can be written as A congruent to B modulus M by, in place of C, we are writing GCD of C comma M. If C divides M. So this is what we got. So from this, if GCD of C comma M is equal to 1, then we can write it as A congruent to B modulus M. If this denominator is 1, then we can say it as A congruent to B modulus M. So finally we need to show if GCD of C comma M is equal to 1, then we can say it as A congruent to B modulus M. This is what we need to show. Our statement says, if AC congruent to BC modulus M, then A congruent to B modulus M only if GCD of C comma M is equal to 1. So hence we have derived that A congruent to B modulus M only if GCD of C comma M is equal to 1. Hope you understand these theorems. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.